Good morning, class. To complete our look at quadratics, we have one last lesson, and it is entitled The Graph of the Parabola. The equation of a parabola is given by y equals ax squared plus bx plus c. So you can see that it's quadratic in nature. This is a parabola with a vertical axis of symmetry. If the parabola has a horizontal axis of symmetry, then you would have x equals ay squared plus by plus c. But we will focus on this type of parabola. So there are two choices then if the axis of symmetry is vertical. The parabola may open upward. This will be when the value of a is positive. Or the parabola will open downward, and that would be if a is a negative value. We will locate the coordinates of the vertex. So the vertex is the extreme point on the parabola. For a parabola that opens upward, the vertex is the lowest point. And if the parabola opens downward, the vertex is the maximum or highest point. The formula Vx equals negative b over 2a will give us the x coordinate of the vertex, and we can substitute to find the corresponding y coordinate. We're going to be finding the intercepts. For a y-intercept, we substitute x equals 0. So this will be the place where the parabola crosses the y-axis. If you substitute x equals 0 into this equation, of course, you will get y equals c. So the ordered pair will be of the form 0c. We will find the x-intercepts by substituting y equals 0. So we will have 0 is ax squared plus bx plus c. And again, that's substituting 0 right here. And then we will solve the quadratic. Now, of course, there are three possibilities. There may be no real number answers. This would mean that there are no x-intercepts. There may be only one repeated real root. So this would correspond to then one x-intercept. And the final case, of course, there will be two real solutions. And this would correspond to two x-intercepts. We will state the equation of the axis of symmetry. Again, this will be the vertical line that divides the parabola into two equal halves, and its equation, it's a straight line and it's vertical, so its equation will be of this form: x equals v at x. Remember, v at x is the x coordinate of the vertex. And lastly, we'll locate one additional point on the parabola, this very specific point, which is opposite the y-intercept, but on the other side of the parabola. The coordinates will be 2 times v at x, and the height will be c. Okay, so I'm going to just go through the first example with you, and then I'd like you to try the next two. So let's get started. Here we go. So the equation is negative 3x squared plus 10x minus 4 is equal to y. So that's our equation, and now let's run through the necessary steps. So first of all, does this parabola open up or down? Well, the value of a is negative 3. The value of b is 10. The value of c is negative 4. So focusing on the concavity here, since a is equal to negative 3, the parabola opens down. Okay, which means that there's a maximum point called the vertex. So let's go ahead now and determine where that vertex will be. So first, we work out v at x by using the formula, the negative of b over 2a. So in this case, that's the negative of 10 over 2 times negative 3. Okay, so we end up with the negative of 10 over negative 6. So this ends up positive 10 over 6, or positive 5/3. And for the purpose of graphing, we may want to write 1 2/3. Okay, now we need the corresponding y value. Okay, so in order to get that, we have to substitute 5/3 or 1 2/3 into this equation where x is. So I'm going to call that v at y. So we're taking negative 3 and multiplying it by the square of 5/3. And then we'll do plus 10 times 5/3 minus 4. So I'm going to just do this with my calculator. Okay, so I'm going to use the fraction button to help me out. So you can watch here, but negative 3 times, and I'm going to put 5/3 in a bracket, 5/3, okay, 5/3, I pushed this button, 5 over 3 squared, okay, so negative 3 times 5/3 all squared, plus 10 times 5/3 minus 4 equals 4 1/3. Okay, so this means that the vertex has coordinates 1 2/3, comma 4 1/3. So far we have the parabola opening downward from this maximum point. Okay, let's continue. Let's work on the y-intercept. So for a y-intercept, we substitute x equals 0. So if x is 0, that gets substituted here and here. You can see we're going to get y equals negative 4. Okay, so this is the point 0, comma c. And that is the y-intercept. And now we'll determine the x-intercepts. We do that by substituting y equals 0. So here's our equation. If we substitute y equals 0, we will have the following. Okay, which can be solved, as you know, by factoring, by using completion of the square, or by using the quadratic formula. Okay, this one has a product of positive 12 and a sum of 10. So it's actually not factorable. So I'm going to use the quadratic formula. I already have the values of a, b, and c stated here. So we do the negative of b plus or minus the square root of, so here we need b squared minus 4 times a times c, and in the bottom is 2 times a. Okay, so let me put in my square root sign here. And as we know, we must figure out this determinant. So in the denominator, I will have the number negative 6. So let's work out the discriminant. It's actually 100, and then it's minus 48. So the discriminant is equal to 52. Okay, if you wanted to do that with your calculator, I mean, I can show you just to confirm that. So 10 squared minus 4 times negative 3 times negative 4. See what it looks like in the display? And that's 52. Okay, so if we wanted to reduce this here, we could make it equal to 2 times the square root of 13. Okay, but we're actually more interested in getting some decimal values here so we can make a graph. So instead of doing that, we're going to work out our two values, and I'm going to round these values to 3 significant digits. So I have to do negative 10 plus the square root of 52, push equals, and then divide by negative 6. So that's going to give me 0.465. That would be 3 significant digits because this leading 0 is non-significant. Okay, and now I'm going to do negative 10 minus the square root of 52 and divide that by negative 6. 3 significant digits here would be 2.87. So these are the two x values corresponding to the two x intercepts. For each of these values, y is 0. So don't put these together in an ordered pair, but rather give each a corresponding y value equal to 0. Like that, okay? So these are the x intercepts. Okay, a couple more things in our analysis. The next thing would be stating what the equation of the axis of symmetry will be. It's going to be of the form x equals v at x. So in this case, it's of the equation x equals 1 2/3. So this is a straight line equation. It's a vertical line. So this is the axis of symmetry. And lastly, for the one additional point, we're going to use specifically the mirror point of the y-intercept. How is it formed? We start by doing 2 times v at x, and then the corresponding y value will be c. Okay, so what is 2 times v at x? So we do 2 times, if you want to put in 1 2/3 as a mixed fraction, it's done like this, by the way. 1 and 2/3. That says 1 2/3 to the calculator, okay? Push equals and you get 3 1/3. So that's the 2 times v at x value. And then we use c as the corresponding height. And c, of course, is -4. So this is the additional point we're going to use, this very specific point. Okay, so now when we construct a graph, we would want 1, 2, 3, 4, 5 points graphed, plus the axis of symmetry labeled. Okay, so then rather than drawing the graph, I actually used Graphmatica to construct the graph, but I'm going to show it to you now, and we'll go over all of these main points on it. So here's what I got for my corresponding graph. So let's start. Does it open down? Certainly. Does it open down from this point, 1 2/3, 4 1/3? So that is here. This is the vertex. Okay, so it's 1 2/3 units to the right and 4 1/3 unit up. So that's the vertex right there. The y-intercept is at 0, -4. Right here, that is where the parabola crosses the y-axis. The x-intercepts, okay, so this is just under 0.5, and here, you know, just under 3. And you can see that those are the two places that the graph crosses this horizontal axis. So they are the x-intercepts. The equation of the axis of symmetry, this right here line that I have drawn in, which runs through the vertex, its equation is x equals 1 2/3. Finally, the additional point we found, 3 at 1/3 -4, is right here. So again, it is directly opposite the y-intercept and on the other side of the parabola. Okay, so that's what I wanted to go through with you this morning. So what I'd like for you to do is try that exact same analysis on problems 2 and 3. I have posted the final graphs for you with all of the relevant information highlighted on those graphs. Okay, so please give those a try and certainly let me know if you have any questions. Thanks a lot.